All right, this is problem number 32 of our related rates problems, and it reads, a highway patrol airplane flies 3 miles above a level straight road at a constant rate of 120 miles per hour. The pilot sees an oncoming car and with radar determines that at the instant that the line of sight distance from the airplane to the car is 5 miles, the line of sight distance is decreasing at the rate of 160 miles per hour. Find the car's speed along the highway. Okay, guys, and we've got a partial picture here. We've got our airplane. You can kind of see the airplane here in the red. So we've got our airplane, and it flies 3 miles above the level straight road. It doesn't talk about the airplane going up or going down, but it's strictly 3 miles above. So immediately in my picture, I can label the height of the plane 3 miles above. That's a constant. That's not going to change in the problem. All right. The pilot sees an oncoming car. And again, sees, we're talking about this line of sight distance. And so that would be a line from the plane to the car. The car is the green vehicle down here. So the straight line we'll go the straight line from the plane to the car. You got that distance right there. And that distance, let's see what that is. Let's call that distance the line of sight distance. We can call that S. So let's call it whatever, L for line of sight distance. So that distance is L. And determines the line of sight distance from the plane to the car is 5 miles. So we can say L equals 5. And the line of sight distance is decreasing at the rate of 160 miles per hour. So rate, we know that's a derivative. Decreasing, we know it's going to be negative. We've got 160 miles per hour, so we can say dl dt is negative 160. Okay? Find the car's speed along the highway. And again, we've got our L label. We've got our up and down coordinate is 3. So back and forth, we'll call that x, that distance. And we'll note right away the car's speed is going to contribute to dx dt. And that's going to be our initial question. What's dx dt? But as we're doing that, we know, wait, the car is going in my picture here to the left. That contributes to x getting smaller, but the plane is also going right. That also contributes to the x distance getting smaller. So once we find the x dt, we're going to have to come back up and do a little interpretation on the fact that the plane is also going 120 miles per hour. So we haven't worked that into the problem yet, but that's part of dx dt, the plane's contribution. The plane going to the right contributes to dx dt, or contributes to x getting smaller, and the car going left contributes to x getting smaller. So we're going to work that 120 miles per hour into the problem at the end. Okay, but our question relates to dx dt. So we need an equation that relates x and L and 3. And again, this is probably our 11th homework problem, so no big surprise. How about the Pythagorean theorem? We'll go x squared plus 3 squared equals L squared. We will take the derivative with respect to time. And we take that derivative, x squared, we get our 2x dx dt. And again, that 3 is a constant because the plane is flying 3 miles above a level straight road. So 3 is a constant, the derivative constant goes away. And on the right side, we get 2L dl dt. All right, just to make things slightly easier, we can cross off the 2's. And let's figure this out. How much is x? Well, we look back up here, we had when L was 5, and the height here, our y was 3. So with the Pythagorean theorem, we can have 3 squared plus x squared is 5 squared. You will recognize that as a 3, 4, 5 triangle. So x is 4. So sub in the 4. Dx dt is what we're looking for. L is 5. And dl dt is negative 160. So just a little bit of math here. So dx dt, let's see, 5 times negative 160 is negative 800. We'll divide by 4, and we get negative 200, and our units would be miles per hour. And initially, the police officer is really excited. It's like, man, you've got a big-time speeder here going 200 miles per hour. But on closer look at that car, first of all, that car does not look very fast. And then you also consider the fact, oh, wait a minute. the plane is contributing right here, guys, 120 miles per hour of the x getting smaller. So since your x is decreasing at negative 200 miles per hour, but the plane's contribution, was negative 120 miles per hour, what's left is the car's contribution. So 120 taken away from 200. So the car must be contributing the other 80 miles per hour. So how fast is the car going? 80 miles per hour, because the XDT was 200, but that was caused by both the car and the plane. The plane contributed 120 of that, so the car must be contributing the last 80 miles per hour. That completes our problem.